So let's go in a little bit more depth about how Spark works. Under the hood, there's something called the Resilient Distributed Dataset object, and it's kind of the core of everything Spark does. So let's dive in and figure out how that works and some of the things you can do with RDDs. All right, so let's stop being all high level and hand wavy and talk about how Spark really works from a technical standpoint. So we're going to talk about RDDs, the Resilient Distributed Dataset object in Spark, and that's sort of the core object that everything in Spark revolves around. Even for the libraries built on top of Spark, like Spark SQL or MLlib, they're also using RDDs under the hood or extensions to the RDD objects to sort of make them look like something a little bit more structured. But if you understand what an RDD is in Spark, you're like 90% of the way there in understanding Spark. So let's talk about RDD in sort of reverse order because I'm weird like that. So fundamentally, it's a data set. It is an abstraction for a giant set of data. And that's the main thing you need to know as a developer. You know, what you're going to do is setting up RDD objects and is loading them up with big data sets and then calling various methods on the RDD object to distribute the processing of that data. Now, the beauty is that although RDDs are both distributed and resilient, you know, they can be spread out across an entire cluster of computers that may or may not be running locally, and they can also handle the failure of specific executor nodes in your cluster automatically and, you know, keep on going even if one node shuts down and redistribute the work as needed when that occurs. But you don't have to think about those things. That's what Spark does for you, and that's what your cluster manager does for you. So even though an RDD is distributed and resilient, which is a very powerful thing, you don't have to worry about the specifics about how that works because it's kind of magic. All you need to really know as a developer is that it represents a really big data set, and you can use the RDD object to transform that data set from one set of data to another, or to perform actions on that data set to actually get the results you want from it. Now, from a programming standpoint, you're going to be given a Spark context object. Now, remember when we first tested out Spark just to see if it was running, we ran something called PySpark, which gave us an interactive shell for Spark. And that gave us an SC object automatically that we could use to run operations on. Once you have that Spark context, you can use that for creating RDDs. And it's a little bit more useful, obviously, to have a script that you can actually run over and over again. So in the case where you're actually running a standalone script, you will create that SC object by hand and initialize that the way you want to. But either way, the SC object stands for Spark Context, and it is sort of the starting point that you have from a programming standpoint. And that SC object gives you methods you need to actually create an RDD. Now, one simple example is that you can use the sc.parallelize function to take a hard-coded set of data and make an RDD out of it, but that's not very interesting. That's not really going to be useful in a real production setting, because if you could hard code the data, then it's not really a big data set to begin with now, is it? More often, we're going to be using something like sc.text file to create an RDD object. So for example, if I have a giant text file full of, movie ratings data, for example, on my hard drive, we can use sc.text file to create an RDD object from the Spark context, and then we can just use that RDD object going forward and process it. Now again, if I have a set of information that fits on my computer, that's not really big data either, but you can also create a text file from an S3 location or from an HDFS URL. So these are both examples of distributed file systems that can handle much larger data sets than what you might be able to fit on one machine. And you can just as easily use an S3N or an HDFS URI as well as a file URI to load up data from a cluster or from a distributed file system, as well as from a simple file that might be running on the same machine as your driver script. You can also create RDDs from Hive. If you have a Hive context object that's already been connected to an existing Hive repository, you can create an RDD from that. If you don't know what Hive is, then don't worry about it, but Hive is basically another thing that runs on top of Hadoop that is for basically data warehousing. And you can also create RDDs from things like JDBC. You can tie it directly to any SQL database that has a JDBC or ODBC interface. You can also use popular NoSQL databases like Cassandra. And it has interfaces for things like HBase and Elasticsearch and a lot of other things that are always growing all the time. Basically, any data format that you can access from Python or from Java, depending on what language you're using, you can access through Spark as well. So you can load up JSON information, comma-separated value lists, and you can also talk to things like sequence files and object files, and also load compressed formats directly. So there's a lot of ways to create an RDD. So pretty much whatever format your source data might be in, odds are you can create an RDD from it in Spark pretty easily. So one common thing you're going to do once you have an RDD is transform it in some way, shape, or form. And these are some of the basic operations you can do on RDDs. It's not a complete list, but these are all of the most common operations that you can do on an RDD. And it's not that long of a list, is it? So there's not a whole lot to wrap your head around here. The thing is, although there's not a lot of different operations that you can do to transform an RDD, they're all very powerful. So let's start with the map function on an RDD. That allows you to take a set of data and transform it into some other set of data given a function that operates on the RDD. So for example, if I wanted to square all the numbers in an RDD, I might have a map that points to a function that just multiplies everything in that RDD by itself. And what the map function does is it has a one-to-one relationship so that every entry in your original RDD gets mapped to a new value in your new RDD. So your new RDD will have just as many entries as your original RDD. Now, flat map is very similar, except it has the capability to produce multiple values for every input value that you have from the original RDD. So the RDD that you transform using flat map may be larger or even smaller than the RDD you started with. But still, fundamentally, it transforms one RDD into another using some function. It just has the ability to blow that out into multiple results or even no results per original entry. Also, the filter operation can be used to trim out information you don't need. So let's say, for example, you have an RDD filled with weblog data, and you want to filter out everything but error lines in that weblog. You could have a filter function that just looks for the word error in a line of text, and if it doesn't have error in it, it throws it away, and that's what a filter would do on an RDD. And then there are some less common operations here, like distinct, if you just want to get the distinct values, the unique values that are in an RDD and throw out all the duplicates. You can call sample on it if you just want to take a random sample from the RDD and get a smaller data set to work with and experiment with. That can be very useful while you're testing a script on a large data set and you just want to run it locally to work out the bugs. And finally, you can actually do intersections of various types between two RDDs. So there are methods that can take two different RDDs as input and output a single RDD that is the union of the two, or the intersection, or subtracting one's values from another, or even the Cartesian product where you get every possible combination between every element in the RDD. And obviously that blows up really quickly. So again, not a lot of different operations, but they're all very powerful, and they allow you to input your own functions for transforming one data set into another using RDDs. Here's an example just to make it a little bit more real. So let's say we have an RDD that's just hard-coded to contain the values 1, 2, 3, and 4. In Python, I could just say rdd.map and pass this lambda function of x points to x times x. And that one line will go ahead and square every value of that original RDD, and it will return a new RDD that contains the values 1, 4, 9, 16, which are the squares of 1, 2, 3, and 4. What was that lambda thing? Well, if you're kind of new to Python, that might be a new concept for you. Basically, a lot of Spark is kind of centered around this concept called functional programming. It sounds fancy, but it's really not that complicated. The only thing is, many of the methods on RDDs actually accept a function as a parameter, as opposed to a more typical parameter like a float or a string or something like that. Instead, you're passing in some function, some operation that you want to perform on every value of the RDD. And lambda is just shorthand, really. So it's exactly the same thing as passing in a function directly. So just like I could say rdd.map lambda x gets transformed into x times x, I could just define a function called squareIt, or whatever I want to call it, that takes x as a parameter and returns the square of that argument. And then I could say rdd.map and then the name of that function. It does exactly the same thing as this line. This is just a little bit more compact. And for simple functions that you want to use for your transformations on RDDs, that can save you a little bit of typing and a little bit more clarity. If you do want to do something more complicated while you're mapping one RDD into another, you probably do want to write a separate function for it, and that's an option too. But yeah, the basic concept is that you're passing in functions to your RDD methods instead of, more traditional parameters. And that's all there is to that. I mean, that's all there is to functional programming, really. It wasn't that complicated, right? It'll make more sense the more examples we look at. And in addition to transforming one RDD into another, you can also perform actions onto an RDD. So once you have the data that you want into an RDD data set, you can then perform an action on it to actually get a result out of it. So you can call collect to just, dump out all of the values that are in there right now and just print them all out or whatever you want to do with them. You can get a count of all the values that are in it. You can call count by value, which will actually give you a breakdown by unique value of how many times each value occurs in your RDD. There are things like take and top that let you sort of sample a few values from the RDD final results. And more powerful is the reduce function, which actually lets you, again, write a function that lets you combine all the different values for a given key value and boil things down into a sort of a summation or some sort of aggregation of your RDD. And that'll make more sense as we look at more examples. There are more examples of actions you can do as well, but these are the more common ones. And another thing to understand with RDDs is nothing actually happens until you call an action. And we talked earlier about how Spark is so fast because it constructs this directed acyclic graph as soon as you ask for an action to happen, because at that point it knows what actually needs to be done to get the results that you want, and it can compute the most optimal path to make that happen. So it's important when you're writing your Spark driver scripts that your script isn't actually going to do anything until you call one of these action methods. And at that point, it will actually start farming things out to your cluster or run it on your own computer, whatever you've told it to do, and actually start executing that program. So you won't actually have any results or any processing whatsoever until one of these action methods are actually called within your script. So important to keep that in mind. So that's what an RDD is. It's sort of the foundation of Spark. So now that we understand how to use RDDs and what they're for, let's go back to that ratings histogram example and figure out what it's actually doing under the hood there.